Hey you guys, so I'm just checking in post Hurricane Florence to see how everybody's doing and just to maybe catch up with a little bit of stuff that we are obviously missing out on because we're not in class this week. I hope everybody is doing okay. If you are not doing okay, I would love for you to send me an email so we can figure out a way to get you some assistance. So I have no idea when we're going back to school. It is currently Friday the 21st, and I was hoping we'd be back in school on Monday, but it is looking like that is probably not going to be the case. So I'll probably start planning to be in school on Wednesday, and I'm hopeful that that will happen, but I'm not sure. So just keep reading your emails and attending to the university announcements and things like that. Okay, so I wanted to go over some stuff from the homework because I probably won't have a chance to do this in class, so I wanted to do it for you guys here, and so I have one pulled up in front of me so I can kind of talk to you about it. So this is about problem set 4, the one that I gave out to you guys in like a separate handout, and it was all about like the hypotheses and type 1 and type 2 error and stuff like that. So I want to just talk through all the answers for it so that you guys would have words to go with some of the things that I commented on your different papers, because sometimes it's hard to write as much as I really want to say on every single paper. So we're going to just go through all of it. So for number 1, it said figure the standard deviation of the distribution of means for a population with a standard deviation of 20 and sample sizes of, and then it gave you different sample sizes for parts A, B, C, and D. So for that, you were just using the distribution of the standard deviation of the means like formula. So that was like the little sigma with the M next to it, or if you're talking about samples, it's the S with the M next to it. So like you would just take the regular standard deviation of 20, divide it by the square root of 10, and that would give you your answer because the number of people in the first sample was 10. So the only thing that people really missed here was that they forgot to take the square root of n and they were just dividing by regular n, and that would obviously give you the wrong answers. So if you got those wrong, just make sure you go back through and can do them. We'll be doing them for our t-test stuff because we have to solve for standard error in step 2, okay, of our t-test stuff. Okay, for number 2, how would you write the hypotheses for a one-tailed and two-tailed test using symbols? You guys did excellent on this question. I was super proud of you, and I was very happy. So I know that when I ask you this on the exam, you're going to know how to do it. So just make sure that you go back over that one more time, make sure you're good with it, but in general, no issues here. What is the difference between a one-tailed and two-tailed test? Lots of different correct answers for this, okay? So I'm going to talk through this a little bit so that you know exactly kind of what I was going for. So in a one-tailed test, the researcher has some kind of hypothesis about which group's mean or average is going to be higher than the other groups, okay? So we've been talking about like you have a sample of people and you're comparing it to a population. Well, if you, or you being the researcher, if you have some kind of hypothesis about one group's mean being higher, then you're naturally going to do a one-tailed test. Okay, so you might think the population's mean is going to be higher, or you might think that your sample mean is going to be higher. But if you have a prediction about that, then you're using a one-tailed test, okay? For a two-tailed test, that's when you're saying, okay, I think my sample is going to have a different mean than the population mean, but I'm not sure if it's going to be higher or lower. I just think it's going to be different, and I'm not sure if it's going to be higher or lower. That's fine. That just means you're running a two-tailed test, okay? So that's sort of the answer that I was going for here, but I got a lot of stuff. Like some of you just said, one-tailed tests are used with directional hypotheses, and two-tailed tests are used with non-directional hypotheses. That is correct. And that was fine. I was just looking for other stuff too. So Let's see what else. Some people would just say that, let's see, what does this one say? Oh, some of you were saying like a two-tailed test is more conservative. That's true, right? Because if you're taking your 5% that you're working with in terms of your type 1 error and you have to divide it up across two tails, then yeah, it's more conservative because you have to find a bigger difference to say you're going to reject the null. Good job. That made sense. If you had anything else for that you want to ask me about, just send me an email and I'll respond to you. Okay. Then the next part was which one goes with a directional hypothesis and which one goes with a non-directional hypothesis. You guys nailed this one. I think pretty much everybody got this right. But if you had any issues with it, feel free to let me know. The sunshine is coming out. Maybe put my glasses on. That'd be weird. Hey, isn't it happy to have sunshine post-hurricane? That's nice, right? Yay. Okay. Let's see. Okay, number 3. Describe what happens to your likelihood of rejecting the null if you change your p-value from 0.05 to 0.01. This one is tricky, okay? So, I'm saying you're changing your p-value from 0.05 to 0.01. So if you're imagining this curve, right, the beautiful normal distribution curve that we have a cutoff at 0.05, all right? If I push that cutoff further into the tail for a 0.01, what I'm doing is I'm making it harder to reject the null. I'm making it less likely that I'm going to be able to reject the null, right? Because I'm pushing the cutoff farther into the tail. So my chance of my t passing that cutoff is lower, okay? It's less likely. Okay, so the answer to that was that if you change your p-value from 0.05 to 0.01, you're reducing or decreasing your likelihood of rejecting the null hypothesis. Now, questions 3 and 4 were sort of similar because question 4 is how does changing the p-value from p equals 0.05 to p equals 0.01 change your chance of making a type 1 and type 2 error? Well, the p-value essentially is your type 1 error, your chance of a type 1 error, okay? So if you change your chance of a type 1 error from 5% to 1%, you're making it smaller, right? So you're making your chance of the fact that you're going to reject the null, say that your study worked, when in real world it wouldn't have worked. Your chance of that is smaller, okay? That's your type 1 error. So you're changing it from 5% chance of a type 1 error to a 1% chance of a type 1 error. But we know that type 1 and type 2 errors are, what's that, like reciprocal. So like they can't, you can't push them both down. So obviously, if you make your type 1 error smaller, you automatically make your type 2 error bigger. Okay, so your chance of failing to reject the null, okay, when the null technically should be rejected, that chance is getting bigger, right? So now if you've changed your p-value from 0.05 to 0.01, you're increasing that type 2 error, okay? The chance that you're going to say, oh, my study didn't work, when in the real world maybe it did, or it would have worked, okay? So that's that for number 4. For number 5, for our p-values, most of you guys got this. If you didn't get it, you got them just generally mixed up, the 0.05 thing. So if your p-value is less than 0.05, okay, if your p-value is less than 0.05, it is statistically significant, okay? So for A, the p was 0.821. That is not less than 0.05, okay? That is above 0.05. That's 0.821, so it is not statistically significant. For B, it was 0.006. That is less than 0.05, so yes, it is statistically significant. For C, it was 0.032. That is less than 0.05, so yes, it is statistically significant. The next one, p-value of 0.521. That is above 0.05, so no, it is not statistically significant. And then the last one is 0.001. that is less than 0.05. So yes, it is statistically significant. You guys, on number 6, I completely messed this one up and I had to send out that email. So what this question was supposed to say was, a psychologist hypothesizes that a new medication will be more effective at treating diabetes than current medications. So if you reject the null, what does that mean about your medication? Okay, so I just wanted you to be able to tell me that if you're rejecting the null hypothesis, that means that you're finding support for your hypothesis, which is your hypothesis is that the new medication is more effective. So in your study, you have found that the new medication is more effective than the old medication. Okay, so that was sort of that takeaway message there. In general, doing pretty good with these. These are the conceptual types of questions that are going to come up on the exam. So if you're still struggling with any of that and you're not sure how to make sense of it, please send me an email or come see me during office hours so we can get that sorted before exam 2. Okay, I'm signing off, and I'll probably be emailing you shortly so that you know that I made a video and so that you know I'm checking on you and see how you're doing.